All right, we have collected our data, and I'm actually going to use data from 2018 when I show you what it looked like. So let's see what we got. Here is what our normal model looks like. And again, this data was collected in January of 2018 from my students. So see, I had all of these ones. Now, let's first talk about what would the distribution look like if our data came from the New Jersey factory. Well, the New Jersey factory claimed 24% blue. So see, this formula here says that, okay, whatever proportion they say is going to happen, that is where the average of all of those P hats will be. So wherever the M&M's factory says, that's where the average of all of those P hats will be. Okay? So that's what we find. That's what we would expect. And so that's what I drew right here. I put 0.24 in the middle because that's where our average of all of our P hats would be. They would be centered there if these came from the New Jersey factory. Now, then there's also a formula for how we can compute how varied our samples would be, and that is this. So the standard deviation, so how varied, see look, standard deviation of the P hats. So this tells me how varied all of our samples should be. And that is based off of, what the M&M's company said, the P, the 0.24. And then you see this number right here. This is the 1 minus 0.24. That's the opposite. So if 0.24 is success, the top, one part, the other part is 1 minus that, so 0.24, and then 0.76, because those two add to 100%. And then we divide by N. N is the sample size that we have. So what size sample did we have in our M&M's lab? We had size 50. All right, so here we go. So we put these numbers in here. So of course, if our data came from New Jersey, it's centered at 20.24. And then here I did the math. I put 0.24 times 0.76 over our sample size of 50. And then I square root that. That's 0.06. So look at what I have here. See my red? 0.24, 0.30, 0.36. So these numbers are one standard deviation up, and then these numbers are one standard deviation down. Okay? All right. So that sets it up. So in essence, we can kind of even anticipate if this data comes from the New Jersey factory, then look, 2 standard deviations. Here is where all the data should be if it is within 2 standard deviations of the mean. So essentially, if I have anything outside of that, it would be considered outliers. And so that's what I wrote here. If the M&Ms came from New Jersey, then I would probably not have these sample results out here. Technically, I probably wouldn't even have these ones that are on that 2 line, okay? So there's 6, 7, 8, 9, 10, 11. There's 11 samples that I probably would not have gotten if these came from the New Jersey factory, or I should not have gotten. All right, so you can kind of see what's going on here. So I bet you have your suspicions on where these M&Ms came from. So let's see what our questions are. If these M&Ms came from New Jersey, where would 95% of all the P hats of all of everybody's samples fall based on just because of sampling variability? All right, 95%. That should sound like something. Within 1 standard deviation of the mean is 68. Within 2 standard deviations of the mean is 95. So that tells me, once again, all of the samples in here are just because sampling variability. You got different data than me because of sampling variability. Okay? So there's where I put those numbers from 12% up to 36%. Okay. If our M&Ms came from New Jersey, would our data have any outliers? If so, how many? Well, that's these 5 over here. For sure, these 5. Technically, I mean, it might even be these ones that are right on the line. Okay? So there is those 5 samples that have a proportion that are more than 2 standard deviations away from what they are expected to be. After seeing this class results, what do you think? Do you think our M&Ms came from New Jersey or Tennessee? I think just looking at these 5 outliers doesn't say the whole picture. If I see it like this, that kind of tells me what's going on. In fact, here is also another picture. So look at this. This is actually what some of my other classes did earlier in the year. Here is this normal model right here. Look, I'm going to center it at 0.24. So here is where the data would be centered if it was from the New Jersey factory, okay? But our data really looks more like this. And guess where the mean for this is? Wow, right at exactly 0.20. And a little secret, I had made these samples with beads, and so I knew the exact proportion, and so I knew it was 0.20 before we started. And so there you go. It had come out to center around exactly what the center was where it should have been. Okay, so based on that, I think that these are coming from the Tennessee factory. If our data was from the New Jersey factory, we would have had 5 samples. But if they were from Tennessee, where I think they probably were, we would have no outliers. They would have all been within 2 standard deviations. Okay, so what we need to remember is these formulas. We actually don't have to have it memorized. These will always be given to us. So the center of all our samples should be centered where they are claimed, the claimed percent is. And then this is telling me how varied, how big the standard deviation for our samples is allowed to be or is going to be. And then from that, we can then now do normal model math because I have this normal distribution of data, unimodal, symmetric. And so let's now take this to an actual example. Here we go. Let's put this into action. So here we start with a simple random sample of 1,785 adults. And we ask them whether they attended a church or synagogue during the past week. And it's claimed that 60% of the adult population does not attend a church or synagogue during any randomly selected week. So we take a sample. What's the probability that the sample proportion of those who did not attend is at most, got to think about what that is, at most 58%. And does this call into question the claim of the 60% attendance rate? So let's see. Let's start some math here. One of the things in doing this math is we have to know, I'm going to put this here so I can do this one at a time. So we have to know some of what these letters over here on the left stand for. Okay, so here we go. So this regular old P, plain P, that is, well, poo. I wrote that wrong. Okay, I wrote that wrong. It is claimed that 60% of adult population, so that's the claim. So that is where my samples should be centered, is at 0.60. And so that's what the claim is for the population. And so then do you remember that the center of all the p hats should be at that same place? So 0.60. All right, so there's how you do that there. Do you remember what N stands for? That is the sample size, and they said it was a simple random sample of 1,785 adults. Okay, now we can then do this math, which it's probably going to be wrong because I did it with the wrong. Oh, no, I did it. Yay. I did it with the P. It was, so see, I need to put that P in there, and then there's your 1 minus P, and then there's the N. Okay, so we need to make sure you can do this in your calculator. So we're going to stop a second and make sure you can get that calculated. 0.6 times 0.4 divided by 1785. And then after I've done that whole product and quotient in there, that whole section in there, I square root that result. And I get 0.012. This is wrong because P hat is the sample results. So that's 0.58. All right. And so that's what we want to figure out is what was the likelihood of me getting? So let's see what that looked like. Here we go. Yep. So how would we figure out how unusual something is? Well, we would get a z-score because that's going to tell us how many standard deviations it is away from the mean. So this needs to be your p hat. Let's see how far away it is from the mean of the p hats divided by the standard deviation of the p hats. So there it is. The sample, the p hat, minus the mean of the p hats over the standard deviation of p hats. P hat minus the p over the standard deviation of p hats. And then since the question asked what is the probability that the ones that attend is at most is that much or less. So that's the area I needed to find. So that's why I norm CDF'd this lower amount. So would a z-score such as negative 1.67 call into question this 60%? Does this make me, getting a sample at 0.58, was it unusual? And make me think, whoa, I'm suspicious. That data might not be centered at 60% because that was really unusual? No. In order to be unusual, our z-score needs to be 2 or more on the high side or the low side. This is not more than 2 standard deviations away from the mean, so it could happen because of sampling variability. So this does not make me question the 0.60. All right, moving on. Here's the next one. A quality engineer selects a simple random sample of 300 switches from a large shipment. Unknown to the engineer, it actually contains 9 defective switches. So then we know the true P, we're going to actually, is 9 out of 300. Okay, so 9 out of 300. So that's going to be the actually contains. And when I made this problem, and I forgot to fix it for you guys, I meant for this to be, but this is a sample, but anyway, I had stated it like as a population, but we're going to go with that. So you might not get a population P straight from the numbers. You might have to figure out what that population P is. Okay? All right, so this is actual. So that's the population amount, 9 per every 300. We'll just say that way. Okay, the quality engineer will reject the shipment if he gets a sample that shows more than 5%. So what this looks like is that he's going to see over here, he is going to, if he has more than 5%, then if he gets one of these little samples up here, he will reject the shipment. Okay, what is the probability that the engineer will find more than 5% defective and reject the shipment, even though it shouldn't be rejected? Okay, so sample size was 300. So all of our samples should be centered around 0.03 because that's what is really on the shipment. Okay? Sometimes you get more, sometimes you get less because of sampling variability. You have different data than me because of sampling variability. Now the standard deviation is that 1 or P times 1 minus P. I'm just hitting all these buttons. Okay, so right here, there is that 0.03 times 0.97 over 300. There it is. And then the p hat, the sample we are wondering about, is 0.05. So we got to do our z-score. So to see how far away is that sample, so that's my p hat minus the mean of those p hats over the standard deviation of those p hats. Okay? And that's 2.04. So at least it would take an outlier for me to reject the shipment. So that's good. It would take an outlier. Now, if I go ahead and I check and see if I norm CDF that to see how much it is, norm CDF from 2.04 to 99, only 2.07% of the samples. So there's only a 2.07% chance that I will be rejecting this shipment because it really is a good one and I shouldn't end up rejecting it. Okay, so that's how that works. And so then tomorrow we'll practice some more of these and see how you do. All right.